Hi, my name is Seth, and I'm a staff programmer at Northwestern University. I'll be talking about this class from the Scala standard library called DynamicVariable, and I'll show use cases in the context of DSLs as well as some other things that it's useful for. Just start my timer. So the dynamic in DynamicVariable refers to dynamic scoping and not to dynamic typing. So it's a dynamic variable dynamically scoped in contrast to lexical scope, which is how scope usually works in Scala and in most modern languages. To motivate this, I'm going to show two examples of DSLs where this is useful. This is from the test suite of the language that I work on, which is a dialectic logo. And this is the first version of some converted Java code that we just translated line from line. And we wanted to get rid of some of the repetition since there were lots of test cases like this one. So I've shown in red the parts that we were hoping to get rid of. In order to do the test, we have to instantiate an object, then we call several methods on the object, and then finally we have to dispose of it. Because that object starts a new thread, so that thread has to be shut down. Our next version of this, we took advantage of support for closures in Scala and defined a separate method where that takes a function body that takes the workspace as an argument. So now we've factored out the creation and the disposing of the workspace. But they're still red here because we're having to say workspace every time, both at the top of the body and when we call the methods on it. So the next version of this used Scala's implicit parameter feature and got the red almost down to nothing, which is pretty good and perhaps satisfactory. But I wanted to know if we could get rid of this last little bit. So that's this example. I'll come back to it after I present the class we're going to use.
Wait, can you explain? I've never actually seen that syntax. So you have a lambda where the argument is declared implicit?
Yes. Yes. This is kind of this is an alternate solution. When I show the version that uses dynamic variable, it won't be using implicit. So I'm not going to pile this stuff on top of what's in this slide. But it is an alternative, and yeah, I think this is a syntax that you don't see too often, and yeah, not everyone knows it exists.
Good to me.
The second example, and I borrowed this from a question on Stack Overflow, is a DSL for building GUIs in Swing. So this is adapted from a Groovy book that presented a DSL that looks like this. And the tough part about making a DSL to do this is that you really want the inner items. You have a lot of nesting, and you want the inner items to be able to access the outer ones. So if you have a menu item, that menu item may need to know what menu it's a part of. So that's the second example that I'll show how we can use this dynamic variable class in a DSL context. The more typical kind of non-DSL uses for wanting dynamic scope are when you're trying to avoid having global variables, having global mutable state, but you're also trying to avoid the first way you might think of to avoid it, which is to modify your functions so that they take more parameters, so that instead of accessing something global, they're just accessing a parameter. But this leads to this typical problem where you end up having to add parameters to lots of places in your code, especially even parameters that the function doesn't actually use, right? So in this example, it's really D that, D is the function that actually needs these three objects. But in order to get those three objects all the way from the start of the program into D through a chain of function calls, we accumulate all these extra parameters everywhere. So that avoids having something global, but it leads to cluttered code. So there's a lot of ways you could fix this, but the one that I'm going to present is using this class dynamic variable. And if you've seen the class thread local in the Java standard library, dynamic variable is a very thin wrapper around thread local. So probably some of you are already familiar with that, and some of you aren't. If you know thread local, or if you don't know thread local, thread local is essentially a lookup from the current thread to a value for a variable. So behind the scenes, you have a map from threads to values of some type. And when you access the value of the thread local, you're just doing a lookup with the current thread as the key. So this has enabled us to improve this code again. All the extra parameters to the functions have dropped out, and down in D, where we need to access the value of the variable, the values of these three variables, we reach out to these instances of dynamic variable to get the value. Now, this may look very similar to the global variable solution, right? There is something global here, which is the identity of the dynamic variables is global here. I mean, in this, it could be truly global, or it could just be defined in some enclosing scope that's not shown in this slide. But what we have gotten rid of is the globalness of the value of the values that are stored here. So the values are now particular to the thread that I'm in. And this costs us a little bit of syntactic noise in that we need to dereference the dynamic variable with the value method. But the amount of noise is not too bad. Any questions so far? So, as I said, this is a very thin wrapper around this class from the Java standard library, which was written by Josh Block and Doug Lee. I think it dates back to Java 1.2, but it was flaky at that time and really became solid in Java 5 as part of Doug's work on the Java util concurrent package. This class is not in that package, but it's kind of part of that family. It offers two versions: thread local and inheritable thread local. I'll come back to what the difference between those is later. So, and because it's written by these guys who are, if you look at the source code, you can see that it's written very carefully to be both efficient and thread safe. So, schematically, the four versions that I've shown, I didn't show the Java one with thread local, but you can imagine it. There's a trade-off here between how easy the code is to write and how clean it is in multiple senses, where clean includes avoiding unnecessary readable state and avoiding syntactic noise. So both of these thread local based solutions are kind of compromises, but the Scala wrapper for thread local makes the code both easier and cleaner. this is a only slightly condensed version of the actual source code for dynamic variable. So it has a private inheritable thread local inside it, and it has the getter, the value method, which we already saw. It does have a setter, which I've put in red because if you can avoid using it, I would suggest that you do. It is there, but it's not the it's not the what I would consider the normal way of using this class. The benefit that the wrapper gives you is really in this method with value. So with value takes a new value for the variable, and then it takes the function body. It remembers the current value of the variable, sets the new one, runs your function body, and then at the end returns the value to what it was before. So what this has given me is a stack of values. Every time I call with value, the value that I provide is pushed onto the stack. There's no explicit stack because this is going into the JVM call stack is where these values are actually stored. And then at the end, the old value comes back automatically. So rather than mutating a value, I'm essentially shadowing it by making a new binding, and the old value is only going to be visible on the current thread, since the whole thing is thread local. So if you look at write-ups of thread local for Java programmers, they often recommend exactly that pattern of saving the old value, doing a set, and then restoring the old value. And so the Scala version just encapsulates that use pattern. I put the null here in red because one of the things that's not obvious in the Java version is what happens if I access this variable before I've given it a value. The thread local does have a no argument constructor, and you can't see the null, but it just gives it an initial value of null. So in real Scala code, I would recommend using option instead, but I just use null in the examples in these slides to keep the code short.